A very good morning and welcome back. Some of the students who are learning the network theory course from me texted me about the difficulties which they are facing while solving the questions given in the question bank. And this short video series I'm going to dedicate for throwing light on how to decipher the questions and will provide you the solutions of the questions in which you are facing difficulties. So let us begin with this question, which is given as question number 2E in your question bank. And in this question, what you have to do is you have to actually find out the value of Ix and Vx by using some means, whatever the analysis which are given, some network theorems or node analysis or mesh analysis, whichever you feel like, you have to solve this. Okay. First of all, look at these three resistances which are given in parallel. And I know that it can be reduced as three resistances given in parallel. We can write that the 1 upon R equivalent for this particular thing is going to be like 1 by 6 plus 1 by 2 plus 1 by 3. And this is going to be, we can take 6 to be LCM, 1 plus thrice of 2 and twice of 3. So this becomes actually 6 by 6. This gives that the our equivalent will be nothing but equals to 1. So this whole series or parallel arrangement can be replaced by just 1 ohm resistance. Okay, we can replace everything over here by just 1 ohm resistance. So I will consider that this is nothing but equals to a 1 ohm resistance. Fine. Now I will start solving this question using the mesh analysis technique, and you can see that for mesh analysis technique, what I can write the equations to be as this. First of all, let me assign that, say this is going to be my mesh 1, but I will not write equation for this mesh because it is going to be a super mesh. Since IM1 is same as 3 amperes, therefore I do not need to write mesh equation for this particular mesh. Let me consider this to be something like IM2, and this is going to be my IM3. And there are three meshes because I have reduced this parallel arrangement into a 1 ohm impedance or resistance only. So equation number 1 goes something like this, that IM1 is equals to 3 amperes. And why? Because the current which is flowing in this mesh and the current across this source is same. Okay, so IM1 equals 3 ampere. Now let us write the equation for mesh 2. In mesh 2, what is the total impedance in mesh 2? So it is 6 plus 3, which is 9 ohms into IM2. Anything common between mesh 2 and mesh 3? We see that there is nothing common between 2 and 3. So it's going to be like 0 IM3. Anything common between 1 and mesh 2? Yes, a 6 ohm impedance. So minus of 6 IM1 equals 2. We do not have any source or voltage source. That's why I will take this as a 0 over here. For mesh 3, if I write, I can say that 9 times IM3 plus, because there is nothing common between mesh 2 and 3, so 0 times uh, IM2, actually for the sake of being in sync with what we learned in class, because we are writing for mesh 3, so for other mesh currents it's going to be negative, so minus 0. And anything common between mesh 3 and mesh 1? Yes, we have 3 times IM1, which is common, and there is no source in it. Okay, so from here you would see that minus 6 times IM1, which is equals to 3, should be equals to minus 9 times IM2. And from here you would find that minus 3 times IM1, which is 3 amperes, is equals to minus 9 times IM3. So from these two equations, we'll get a solution that IM2 is going to be 6 threes is 18 by 9, which is equals to 2 amperes. 6 threes 18, minus minus cancels. And IN3 equals to what? This is going to be 9 and 9. So this is going to be 9 by 9, which is 1 amperes. So if I would have to apply mesh transformation means you have to assign the current which is flowing in the branches in terms of the mesh current. So I can simply say that Ix is equals to Im2 minus Im3. This is from what we have already learned in our class. And what is the value of Im2 which we just calculated? 2 amperes. What is Im3? 1 amperes. So we got to know that I of X is equals to 1 amperes. Fine. Now, if you have to solve for what is going to be this voltage or the branch voltage, so can you please tell me what is going to be Vx? It is going to be something like 3 times the current flowing through Vx. Let me call this current to be Iy. So a current through passive sources should flow like this, from positive to negative. And this current can be represented in terms of a combination of these two meshes, because Iy, let me call this current as Iy can be written as Im1 minus Im3. So I can write Iy equals to Im1 minus Im3. Okay, that's what mesh transformation is. So Im1 was equals to 3 amperes and Im3 as we calculated is equals to 1 amperes. So this becomes that Iy, at least we know, is 2 amperes. And Iy multiplied by 3 will give you Vx. So Vx is going to be 3 times 2, which is 6 volts. So 3 ohms and 2 amperes will give you 6 volts. That's how you are going to solve for this particular circuit. And this is it. Thanks for watching.